there's my circuit with just my given values again. So let's see, so I total, let's bring I total back. I total was found to be 4.988 milliamps, and IR2 was found to be 1.675 milliamps. Okay, so we identified before that, you know, IT is also IR1, so we know IR1's current, we know IR1's resistance, so let's solve it. Let's find VR1. So VR1 equals IT times R1. VR1 equals 4.988 milliamps times 1.2k ohms. VR1 equals, let's just solve it right now. Alright, so let's see, clear that, and I've got my I total value stored here in my history, so enter times 1.2 e to the third gives me my current times my resistance for R1, and I'm getting 5.985 volts. Okay, 5.985 volts. Alright. Alright, so now I know IR2 and I know R2's resistance. Let's solve for the voltage of R2. VR2 equals IR2, which we found, times the known resistance of R2. VR2 equals 1.675 milliamps, found earlier, times 1.8k ohms, which is a given. So let's find that. VR2 equals, let's raise that and we'll write it a little bit better. VR2 equals, okay, so let's clear that. So I've got my current of R2 stored in my history, okay, and times 1.8 kilo ohms. I'm getting 3.015 volts, just to see, 3.015 volts. All right, so you remember in my previous equation, the one I actually used to solve this circuit, and then when I was first doing my analysis, I found that these two voltages are equal, of course, and 9 volts, or 0, equals minus 9 volts plus VR1 plus VR2. So I ended up with this equation, so 0 equals minus 9 volts plus VR1 plus VR2, right? So 9 volts equals VR1 plus VR2. Alright, well, let's see if it does. 9 volts equals, well, what did I find? 5.985 volts plus 3.015 volts. Okay, so 9 volts. Let's see if 9 volts equals 9 volts. Okay, so let's bring back the calculator here. And I've just got my numbers stored in my calculator. Let's just use them. So I had my 5.985 volts, which is VR1, plus my 3.015 volts, which is VR2 and VR3. Okay, and I'm getting 9 volts. 9 volts even. Let's just see. No extra digits at all. So that one worked out just perfect. So it turns out 9 volts is equal to 9 volts. And so my double check works. So Kirchhoff, my best buddy, is super happy because so far I've done everything and solved the circuit properly. Now remember that we're almost done here. We still don't know what R3 is. So V R3, if you remember from earlier, equals VR2, right? So we know the voltage of R3 already. All right, so now let's plug in some numbers and solve for R3. So R3 is going to be VR3 over IR3. So that is just a little bit of Kirchhoff or Ohm's law right there. So R3 equals, well, we found that to be 3.015 volts divided by the given IR3, which was 3.313 milliamps. Okay, so let's see, R3 equals, and let me just give a little more space here. R3 equals, let's bring back the calculator. Come on, calculator. Well, let's see. So go grab our VR3 or VR2 voltage divided by our known, whoops, I got some extra stuff in there, 3.015 volts roughly, divided by our given 3.313 milliamps. Okay, so that gives me 909.9. Alright, so probably if it was a standard value, that's probably a 910 ohm. So I'll just say, I'll just go ahead and write it as 910 ohms. Okay, so now we know R3, we know the current of R3, we know the current of R2, we know the current of R1, so we know everything. Well, at least we think we do. If we're feeling super confident, we can stop here. So Kirchhoff was happy with the voltages, so if we wanted to solve some more values, we could get the resistance total. Okay, so I could do this in a couple of ways. So I've got total voltage and I've got total current, so I can find total resistance just using Ohm's law. I can then say I've got R1 in series with this parallel network, so I can find the equivalent resistance of the parallel network here and then add it to R1 and see if I get the same value. So let's just do that real quick. Okay, so I said if I want to find R total, I can just use V total over I total. Okay, so R total equals 9 volts divided by, what was I total? It was, let me go look real quick. Right here, it was 4.988 milliamps. 4.988 milliamps. So let's just see what our total comes out to be using Ohm's law and our numbers that we've got so far. Alright, so bring back the calculator. Alright, so 9 volts divided by, and I've got a saved number up here which will be less rounded than if I just punch it in. Okay, so I've got 1.804 kiloohms. Okay, so that is my R total using Ohm's law, and just because we're double checking, I could use series parallel rules and say that RT is going to be equal to R1 plus, I'll write it mathematically, 1 over 1 over, I know everyone loves this equation, it just looks wonderful. So, but that's basically just going to tell me that it's the parallel equivalent resistance of R2 in parallel with R3 plus R1. Okay, so RT equals 1.2 K ohms plus our reciprocal formula, 1 over 1.8 K ohms now, plus 1 over what we found for R3, which we said, or we found earlier, is 910 ohms. All right. RT equals, let's see, now I can solve that one at a time. I can plug it in and hope that I get everything in the right spot. Let's just do that just to be faster. 1.2 e to the third plus parenthesis 1 divided by parenthesis. Okay, so another parenthesis just to punch it in just like I've written it here. 1.8 e to the third, okay, which is our R2, so reciprocal of R2 plus reciprocal of R3, or the conductance of R3. Okay, so I've got those. Let's make sure I have enough parentheses on this thing. See if I can make the calculator happy about it. So I did manage to get it in there. 1200 plus the 1 over magical, amazing reciprocal formula, the conductance formula. Okay, so it turns out I get the same answer. Let's see. 1.804 K ohms. So essentially I've solved resistance a couple different ways. I've Kirchhoffed and used my voltage loops, my original equations to find or to verify that all these numbers are correct. I mean, I actually had what I needed all the way up here, but I like to double check because, you know, the little math errors are the ones that are really going to haunt you forever. So it's always good to bring Kirchhoff in and double check your answers. I was able to use my found values to solve for RT and using Ohm's law, and then I used just my series parallel rules with my known or my found R3 to verify that I could get the same number two different ways. So I'm going to call this one good, because we have essentially solved everything for this circuit. So if you like this, great. I hope that there's some value in this method. It's not the most clear, cut and dry method, because you do have to analyze the circuit and look for those relationships, those algebraic relationships, as I did in the beginning here, where I created some, basically I just wrote down everything I knew about the circuit in mathematical form. Using that, I was able to find a substitution, and that's the part that I think many of my students seem to struggle with. So just where do I apply it? How do I look at the math and try to make it make sense on my circuit? And so that skill, I mean, it's not to be avoided. That skill will help you to solve much more complicated circuits than this. Just using mathematical relationships. So math, turns out, isn't just a thing that people do. It's a tool for your toolbox. So if you have a little bit of math skills, you just are now more enabled to solve less apparent problems. Okay, so I hope this had value. Thank you very much, and I'll see you next time.